Properties of quadrilaterals. Okay, so we have a few quadrilaterals. We have parallelograms, rectangles, rhombuses, and squares. Remember, these three are parallelograms. There's also a lot of properties that these shapes may or may not have. So before we start this video, you need to either copy down this chart or go back to the Moodle page and either there's a link to a document that has it. You can print it, you can make a copy on Google Docs and use that, however you want, but you should have access to this chart that you can write on as you're, or type on as you're watching this video. Okay, so now that you have that, let's start looking at some of these things. So opposite sides of parallel. So let's just draw a parallelogram. Okay, sorry about my drawing, you'll just have to believe that's a parallelogram. The definition of a parallelogram says that the opposite sides are parallel, right? So are opposite sides parallel in a parallelogram? Absolutely, and we're going to write definition, okay? Now, a rectangle, a rhombus, and a square, all of these things are true because a parallelogram has parallel sides congruent, and they are all parallelograms. Okay, let's look at the next one. If I have this parallelogram, let's call this parallelogram A, B, C, D, right? If I want to see, does AD equal BC? Is that true? How about AB congruent to DC? Is that true? Okay. I'll give you a hint to think about this is connect A and C, and what you've done is you've made two triangles. So see if you can use congruent triangles to prove these things. I want you to try and do this proof on your own. Push pause. Okay, so hopefully you've thought about this. I'm now just going to do a little quick overview of the proof. So what I know is AC is congruent to itself. Angle 1 is congruent to angle 2 because of alternate interior angles. And 3 is congruent to 4 by alternate interior angles. So these two triangles are congruent by angle, side, angle, right? If I'm going to think about this, triangle ABC is congruent to triangle, and so think about the letters again, CDA by angle, side, angle. So then the congruencies are true by corresponding parts, right? So this is absolutely true in a parallelogram, which then makes it true for all of these shapes as well. Okay. Similarly, if I look at the next one, I could absolutely say that opposite angles are congruent, right, by CPCTC. So that's the same thing. And you might think these are a little bit out of order, but these things are also congruent, right? Diagonal forms two congruent triangles. Okay, now take a little bit of time to look at these other properties and maybe make some conjectures on your own. Okay, so for all sides being congruent, we know that that is true for a rhombus, and we know that a rhombus is a square. So those two get checked off. Not true here. No, no. How about diagonals bisecting each other? Okay, so is that true in a parallelogram? So what we know is we have this parallelogram, and we want to know if these bisect each other. Okay, so things we know about parallelograms. We know that their opposite sides are congruent, and we know that lines are parallel, we know opposite angles. So if I look here, I know these angles are equal, and I know these angles are equal, right? What that means is that these two triangles right here, this one and this one, are congruent by angle, side, angle. Make sure that makes sense to you. Which then, by corresponding parts, means that these are equal and these are equal. So the diagonals do in fact bisect each other, right? Definition of bisector means that a segment is cut into two equal pieces. So if it works for a parallelogram, it is true for all of these. Okay. How about diagonals congruent? Well, if I draw just a parallelogram, and I'm going to kind of draw an extreme version, it is pretty clear that those diagonals are not congruent, right? Not congruent. But let's look at a rectangle then. So a parallelogram was no, so here's a rectangle. Okay, things we know about a rectangle. These are equal. These are 90. We want to know if those are equal. This is 90. So for this, think about how you might prove this to be true. I'm telling you it is. If you would like to pause it and try on your own, go for it. But again, if I label this A, B, C, D, do you see how triangle ACD is congruent to triangle BDC? Those two are congruent by side angle side. Please pay attention to that being side angle side and not HL, even though it is a right triangle. It is side angle side. Okay, so if that's true, then by corresponding parts, AC is congruent to BD, right? So that is true for a rectangle. And anything that's true for a rectangle is also true for a square. This is not true for a parallelogram or a rhombus, okay? We'll erase that, and we will try diagonals being perpendicular. I think you can probably tell that in a parallelogram this isn't true. You can also tell in a rectangle, just by looking at it, this isn't true. Let's try a rhombus. Okay. So things we know about a rhombus is that these are all equal. So if I draw these in, okay, I also know by properties is that the diagonals bisect each other, right? That's this property right here, okay? Oh, apologize. This property right here, diagonals bisect each other. It's true for rhombuses. So what that means is these are equal and these are equal. So all four of those triangles are congruent by side, 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 which means that these four angles right here all have to be congruent, right? And if we have two lines intersecting with four congruent angles, they're going to have to be 90 degrees. So diagonals are in fact perpendicular for a rhombus, and so a square, right? Not true here. Okay. Do the diagonals bisect two angles? Again, if we look at this rhombus, we have these four triangles are congruent. So these have to be equal, and these have to be equal by corresponding parts. So, yes, they do bisect the angles. It's true in a rhombus, so it's true in a square. Not true here or here. The last property on here is all angles are right. This is absolutely true for a rectangle and a square, but not necessarily true for those things. Okay? The last quadrilateral we have, it's not on this chart, but we have trapezoids, and we have a special trapezoid, an isosceles one. Okay, an isosceles trapezoid has a couple of properties. One, base angles are congruent, just like in an isosceles triangle. Okay, so that means this angle is congruent to this angle. It also means that this angle is congruent to this angle. So there's two sets of base angles, okay? The other thing that's true is if I drew in diagonals, okay, and I'm going to label this, okay, and I would like to just look at this for a second, and if you could see, look at, let's say, this triangle. Okay, and then let's look at, say, this triangle. See those overlapping triangles? Those two triangles in this isosceles triangle are congruent by side, angle, side, right? Because they have the given side that's congruent, and then they also have bireflexive, AB is congruent to AB, and then this angle and this angle, right? So what that tells us is that diagonals are congruent. Okay, so this is only true for isosceles trapezoids. Okay, so just a special quadrilateral, isosceles trapezoids. Okay, so you have a lot of stuff to know about properties of quadrilaterals, special quadrilaterals.